Today we're going to be taking the stoichiometry problems that we learned how to do yesterday and going 2 steps further with them. The calculations we'll be doing are called mass-to-mass problems. The reason that we need to learn how to do these is because with the problems we learned yesterday, we only were able to calculate things in terms of moles. And we know that if we're in a lab situation, we can't weigh things out in moles to figure out how much we should put in or how much we should expect to get. When we weigh things or predict things in a lab setting, we usually use grams. And so we need to be able to know how many grams are going in and how many grams are coming out. And those are called mass-to-mass problems. The easiest way to learn how to do mass-to-mass calculations is just to do them. So first, we'll start with a simple equation. H2O as a liquid can be broken down into hydrogen gas and oxygen gas. All of the formulas are already here, so we don't need to write any of those. Our question says, if you split apart 72 grams of H2O by electrolysis, which just means running electricity through water, what mass of oxygen gas would be produced? Here are the steps for doing a mass-to-mass problem. First, before you do anything else, check to see if your equation is balanced. This one was not, so we need 2 H2O molecules that will produce 2 H2 molecules and 1 O2 molecule. Step 2, and this is one of the steps further from what we did yesterday. We need to convert the mass of what we know to the moles of what we know. What does that mean? Well, what we know is what was given in the question, and that was given in terms of grams. So, convert the grams of what we know, we're doing factor label again, 72.0 grams of water, to moles of what we know. You already know how to do this. Converting grams to moles is something that we've been doing for several months. So we need to find the molar mass for water. If you don't remember that, you could just add up all the pieces. You need 2 hydrogens plus 1 oxygen makes 18.02 grams of water for every mole of water. So convert mass of what you know to moles of what you know. The grams cancel, divide, check your sig figs, you should keep 3. So 4.00 moles of H2O. Step 3. Convert the moles of what you know to the moles of what you want. And you use the balanced equation to do this. This is the problem that we learned how to do yesterday. Mole-to-mole problems are now going to be our middle step in our mass-to-mass problems. So the moles of what we know, we just did that on the previous slide, and we came up with 4.00 moles of water. Use the balanced equation to convert that to moles of what we want. We know we need to cancel the water, so we look at our equation. There's a 2 in front of the water in the equation. So 2 moles of water. And then refer to our question. What are we trying to find? Oxygen. Look at the equation. There's 1 mole of oxygen in the equation. Moles of water will cancel. We need to divide. Check your sig figs. And you get 2.00 moles of oxygen produced. Step 4 for a mass-to-mass problem is to convert the moles of what we want, that's what we just did, to the mass of what we want. And we're going to use the other molar mass to make that calculation. Remember, this is because we can't predict the amounts of things in moles and then expect to use that in a laboratory setting. We need to be able to predict things in grams so that we have a better idea of how much to expect. Here's our equation again. And here's what we had from our previous step. 2.00 moles of O2. We'll cancel that with 1 mole of O2. And then how many grams are in a mole of oxygen? O2 means take 16 times 2, so that's 32.00 grams for the other molar mass. This time we just need to multiply, check your sig figs, you should keep 3. 64.0 grams of O2. Now this might seem like a lot of work for one simple calculation, but we can make it go faster if we string these steps together. If you remember doing practice factor label problems when we first learned how to do them, you can put multiple steps in one calculation. So if we take the 4 steps that we just went through, the first one was balance the equation, so that doesn't really have any math that goes with it. So take the last 3 steps and put them all together. We did 72 divided by 18.02 divided by 2 times 32. And if you're doing all of your steps together, you need to multiply by everything that's on the top and divide by everything that's on the bottom. The easiest way to do the math for that is to multiply all the way across the top, all the way across the bottom, and then divide. And of course, you still have to check your sig figs. Your sig figs will come from 3 spots in these calculations, here, here, and here. And we're still going to keep 3. When you do it this way, you round once as opposed to rounding at every step. And so your answer may come out just a touch different than it does if you round at every single step. This way is actually more accurate because every time you round off, you introduce a small amount of error into your calculations. This time we only rounded once, so we get 63.9 grams of O2. Let's do a couple more examples. If you produce 10.1 grams of H2, what mass of O2 is also produced? Again, just as a reminder, here's our balanced equation. And now we're ready to do our math. Convert mass of what we know. So what are we given in the question? 10.1 grams of H2. We need to convert that to moles of H2. So the first thing we need to do is cancel the grams. That means we need the molar mass of H2. So look up the mass of hydrogen, add 2 of them, and you get 2.02 grams of hydrogen for every mole of hydrogen. Next, we need to convert moles of what we know to moles of what we want, and this is where we're going to use the balanced equation. We need to cancel our hydrogen, so we look at the equation, there's a 2 here, and we're looking for oxygen. Look at the equation, and there's a 1 here. Then we need to convert the moles of what we want, which is oxygen, to grams of what we want. So we're going to use our other molar mass. Cancel the moles of oxygen. O2 has a molar mass of 32.00 grams. Check your sig figs. Check the 10.1, 2.02, and 32.00. So we should keep 3 and round off to 80.0 grams of O2. Next example has a new equation. So for this new equation, we need to check and see if it's balanced. It's not, so we need 2 NaCl and 2 NaF. Now we're ready for our example question. To produce 140 grams of chlorine, what mass of fluorine must react? Look at what you're given in the question. 140 grams of chlorine. Start with that. We need to convert grams of chlorine to moles of chlorine. That means we need to cancel the grams, so we need a molar mass. The mass of chlorine is 35.45 times 2 is 70.90 grams of chlorine. That's per 1 mole of chlorine. Now that we've canceled our grams, we're ready to go from moles of what we know to the moles of what we want. So now we're going to look at our equation. Look at chlorine, there's 1 mole here. And then we look at what we want, the mass of F2, and there's 1 mole here. It's a 1-to-1 ratio. Now we need to go from moles of fluorine to mass of fluorine. So we need the other molar mass. 1 mole of F2 goes on the bottom so that it will cancel. And we need to look up the mass of fluorine, which is 19.00 times 2 is 38.00. check your sig figs. Check the 140, check the 70.9, check the 38. This time we should keep 4. So we end up with 75.04 grams of fluorine. One more with this equation. If 68 grams of NaF are formed, what mass of Cl2 is produced? Start with what you know. 68 grams of NaF. We need to cancel the grams and convert that to moles. This time we're going to have to add 1 sodium plus 1 fluorine is 41.99 grams of NaF, and that is per 1 mole of NaF. Next step, convert the moles of what you know to the moles of what you want. There's 2 moles of NaF, that's going to go on the bottom. I'm looking for what mass of Cl2. There's 1 mole of Cl2 in the equation, so that goes on the top. And then I need to convert moles of Cl2 to mass of Cl2. So 1 mole of Cl2 goes on the bottom, and the molar mass of Cl2, which we already saw on the previous problem, goes on the top. Check your sig figs. 68, 41.99, 70.9. We're going to end up keeping 4. And again, when you do these, the easiest way to do the math, the most foolproof way, is to multiply across the top, multiply across the bottom, and then divide. If you want to try to do it a little bit faster, everything on the top gets multiplied, everything on the bottom gets divided. So you would put into your calculator 68 divided by 41.99 divided by 2 times 70.9. Either way should get you to the correct answer. Round off to 4 sig figs, you get 57.41 grams of chlorine.